So let us see how to fill the functional table of NAND gate. The functional table includes the number of inputs, number of transistors, and the output columns. Here number of inputs are say x1 and x2, number of transistors T1, T2 PMOS transistors, T3, T4 are NMOS transistors, and then F represents the output. Under two variables, in binary there are four possible combinations. Let me apply each and every one with reference to each combination, represent state of each and every transistor, and finally decide what is the output logical value. Let us take the combination 0, 0. With reference to 0, 0, the PMOS transistor state is on state. Here T1 and T2 are the PMOS transistors, they are in on state, whereas the transistors T3 and T4 are NMOS transistors. With reference to logic 0 input, their state is off state. Therefore, the pull down network totally in the open circuited mode. Hence, maximum voltage is available. That is considered as logic 1. Then apply another combination 0, 1. With reference to 0, 1 input combination, the state of T1, T2, T3 and T4 transistors are represented here, and the corresponding output is logic 1 because the pull down network here also in the open circuited mode. Coming to third input combination, that is 1, 0. With reference to this input combination, the transistors T1, T2, T3 and T4 transistors are represented in the functional table. Here also the output is logic 1 because the pull down network in the open circuited mode. And with reference to last combination, that is 1, 1, both PMOS transistors are in off state, whereas NMOS transistors are in on state. Hence the pull down network is the short circuited mode of operation. Hence the output is very low voltage, hence considered as logic 0 output. Okay. So like that you can develop the functional table for any CMOS structure. Okay. Then let us see how to develop non-inverting gates and complex gates. Coming to non-inverting gates, there are two non-inverting gates are there. One is AND gate and another one is OR gate. Now I explain only the construction of AND gate. After that you develop OR gates. How can you get AND gate? That means it includes or it is a combination of NAND gate and NOT gate. So by joining NAND gate CMOS structure with the NOT gate CMOS structure, you can get AND gate. Let us see. So this is the construction of NAND gate. If you connect the output of this NAND gate to an inverter or NOT gate, totally the circuit works as a AND gate. So this is the construction of AND gate. With reference to this AND gate, you plot the functional table. The functional table includes number of input columns, number of transistors, and only one output column. For each and every input binary combination, first of all you represent the state of each and every transistor. Then observe what is the state of pull down network. Is it in open circuited mode or is it in short circuited mode? If it is in open circuited mode, consider the output is logic 1. Whereas if it is in short circuited mode, consider the output is logic 0. Okay. Then coming to complex gates, there are two types of complex gates. One is AND OR invert gate, simply called AOI gate, and another one is OR and invert gate, simply called OAI gate. Here I explain how to construct AOI gate. Okay. I said already, before going to construct, first of all you need to write the Boolean equation. The Boolean equation of AOI gate is AB plus CD whole bar. Therefore, it has 4 inputs A, B, C, D. Hence, 4 NMOS transistors you need to consider and 4 PMOS transistors you need to take. And let us see what is the connection between NMOS transistors and PMOS transistors. The connection between A and B NMOS transistors is in series because the relation between A and B is product relation. I said already, with reference to pull down network, if the realizable term is product term, the pull down transistors connection is in series. If the realizable term is sum term, the connection of pull down transistors is shunt connection. Okay, so therefore the connection between A and transistors is series. Similarly, the connection between C and D NMOS transistors also series, because here also the product relation between C and D. And see the relation between the term AB and CD, that is a sum relation, hence these two networks connected in shunt. Now with reference to this pull down network, connect pull up network. Since AB NMOS transistors are in series, therefore the corresponding PMOS transistors connection is in shunt. Similarly, since the CD NMOS transistors connection is in series, hence the corresponding PMOS CD transistors in shunt. And the output is considered in between PMOS and NMOS structures or networks. PMOS network is connected to VDD, whereas NMOS circuit is connected to ground. So this is the construction of AOI gates. Then let us see the functional table of it. As you know, the functional table includes inputs, that is number of inputs, number of P transistors, number of N transistors, and outputs. Here the number of inputs are 4, that is A, B, C, D. 4 PMOS transistors are there, named as A, B, C, D. 4 NMOS transistors are there, also named as A, B, C, D. And finally outputs. Since 4 input means there are 16 possibilities, let us take the first possibility is 0, 0, 0, 0. With reference to 0, 0, 0, 0 input, you know the state of the PMOS transistor is on. Therefore, all the PMOS transistors are in on state. Similarly, the NMOS transistor state is off state. Therefore, all the NMOS transistors are in off state because all inputs are zeros. Now observe what is the mode of operation of pull down network. Is it short circuited mode or open circuited mode? Since all the NMOS transistors are in off state, therefore the pull down network in the open circuited mode. Hence the output is logic 1. Like that, apply each and every input binary combination, represent the state of PMOSs and NMOS transistors, and check out what is the operating mode of pull down network. If it is open circuited mode, the output is simply logic 1. Whereas if it is short circuited mode, the output is logic 0. So like that, you can fill the functional table of AND or invert gate. Similarly, you construct OAI gate and develop the functional table of it. Okay. So now see, this is the assignment questions. So one is construct CMOS OR gate, construct OAI complex gate, prepare functional table for both OR gate and OAI gate, and also develop a Boolean equation for the given CMOS circuit. Okay. How can you develop Boolean equation? If the connection is in series, the realizable term is product term. With reference to pull down network, I am talking. If the connection is in series, the realizable term is product term. If the connection is in shunt, the realizable term is sum term. Okay? Right.